And we're back to talk about our second type of curved mirror. Now, I want to remind you, we have two different names for each of these mirrors. So the last video covered the converging mirror. This one is going to cover the diverging mirror. I try to use the terms interchangeably. So remember, a diverging mirror and a convex mirror mean the exact same thing. So a diverging mirror is that idea that the center is going to be bulging towards you, and the skinny parts are going to be away. So the parts of the convex mirror and concave mirror are the same with one subtle difference. So I'll move my face over here now. I feel like my face is always in the way for this. There we go. Okay, so notice here that we have our, let's zoom out so you can see too. We have our converging or our convex mirror. And again, if I was a little stick person standing on this side, the center is bulging towards me. Notice the difference though is where F and C are. So C is still twice the distance of F, but notice that F and C are on the opposite side of the mirror. F and C before were here, F, C. Now F and C are on this side. The reason is because in the name, this is a diverging mirror. So in a diverging mirror, my light rays coming in a converging mirror, they went towards the principal axis. Now they're going to diverge. They're going to go away from the principal axis. So any light rays that I actually draw in this case are not going to cross on this side. I say that ambiguously for a reason, because they're not going to cross on this side. They are going to cross on this side instead. We're going to be dealing with, in this case, apparent light sources. So they're not going to cross here, but we are going to have apparent light sources that are going to cross here. Since my apparent light sources are crossing here, I need F and C on this side in order to locate where my image is. All right, so now that we understand why F and C are on the opposite side, let's just get right to it. Let's get to our different rules. So the good news is the 4 rules that we had on the last mirror are the same 4 rules. If I go in parallel, I'm going to come out through F. If I go in through F, I'm going to come out parallel. If I go in through C, I'm going to come out through C. And if I hit the vertex, my angle of incidence is going to be my angle of reflection. So it's going to be the same rules, but again, we're going to diverge. So we're going to go in the opposite direction. So I've again got my object. It's my arrow. I'm going to take my ruler and line it up at the top of my object, and I'm going to shoot it straight at my mirror. So I've got this line is totally parallel. I'm shooting it at my mirror. As soon as it hits my mirror, it's going to come out through F. Remember, F is not on this side anymore. It's on this side. So I've taken a ruler, and at the exact point that this hit the mirror, I took my ruler and I lined my ruler up through F, as well as through the point in which it hit the mirror. So you can see this is actually a straight line. I've traced on this side a solid line because on this side of the mirror, this is going to be my reflected light. I've traced on this side a dotted line. Why did I trace a dotted line? Because on this side, it's always going to be an apparent light source. This is just where my brain thinks the light is coming from. It's not actually where the light is coming from. So that was my first rule. I'm now going to do the exact same thing with my second rule. This looks a little bit more complicated at first. It's not, I promise. So again, we've taken our ruler and we've lined it up so that we're actually touching the top of our object, and we're also touching F. So if you actually take a ruler and line this up, you can see I've got a straight line where I'm touching the top of my object, and I've also lined my ruler up so it looks like it's going through F. I've drawn in my incident ray, but notice I didn't go all the way to F. I didn't go all the way to F because the second this ray here touches the mirror, it's going to shoot back out parallel in this direction here. Now remember, my eye's over here. My eye is going to see that light traveling from this direction, and it's actually going to trace it back. So I've got my dotted line, and I'm tracing back my dotted line as my apparent light source. So I have 2 lines crossing. I don't have 2 lines crossing on this side, but I do have 2 lines crossing on this side. So this time, I'm going to have my image is actually going to form behind the mirror. So I can go ahead, I can put my image in there. Again, I start my image on the butt of the line, and I draw right up to where that X is. X marks the spot. And we're going to think about how this image is related to this object. This image, if I compare the sizes, looks much smaller. So it's smaller. This image, if I compare the attitude, this is facing upwards. This is facing upwards, so it's considered to be upright. In this case, the location, it's really hard to say where it is. So we're just gonna go ahead and we're gonna say the location is behind the mirror. And again, remember, anytime I'm behind the mirror, anytime that I'm dealing with apparent light sources, those dotted lines, I'm dealing with a virtual image. So in this case, we say that we've got a virtual image because I've got those apparent light sources. This is true of any object in any diverging mirror. So anytime I'm dealing with my diverging or my convex mirror, this is always going to be my salts for those situations. That's it. That's mirrors. That's everything you have to know about mirrors in grade 10. So we are going to talk now not about light bouncing off of things, not about light reflecting. We are going to talk now about light bending or light refracting things. So we're going to start our part 2 of physics next week. And our part 2 of physics is going to look at light traveling through things.